Today I want to talk about Luajit and its foreign function interface. Previous to this, I created some videos on ShaScheme, which is a wonderful implementation of the Scheme programming language. And I thought that that would be great because there's just not a lot of content about Scheme, and ShaScheme is a great implementation that has a great foreign function interface. So I want to do something similar with Lua, and there is already a lot of information about how to get Lua and the basic usage of Lua. In fact, there's even some great videos about game programming with Lua. But one of the things that there's not much content about is the Lua's foreign function interface. Now, I think this is important because if you're going to use some language that's not C or C++, you have to worry about the foreign function interface because there are lots of other libraries out there that you might want to use, such as for cryptography or databases, or even the operating system itself. All of these things expose themselves through a C interface. And even if you want to use some other libraries that have been exported by other languages, such as Rust or Go or Odin or whatever, all of those languages, when you expose those libraries as shared object libraries or DLLs, all of them have a C interface. So that means that if you're going to use a language, no matter what it is, its foreign function interface is essentially how it interfaces with C. And how good a language interfaces with C is essentially how good a language is, from my opinion. So I want to show a little bit about Luajit, which is a little bit different. It's an implementation of Lua. And so its foreign function interface is a little bit different than Lua's. So I want to introduce Luajit's foreign function interface, how to use it, and essentially that's it. Just kind of the basics of introducing the foreign function interface for Luajit. So in order to find information about this, you can go to the luajit.org, and I'll try to have all of these links in the description. And you can read about Luajit itself, and they have pages on here exploring and showing you how to use the Luajit library. They even have a nice little tutorial for you. And then they show you a little bit about how the conversions work between Lua objects and C objects. And then even they've got the semantics about what that means. And this is actually the conversion rules. And then there are also some extensions for Lua that, for example, like string buffers allow you to have this high performance version of essentially string builders that you can have. And so all of that is available here at luajit.org. And then, of course, what I'm going to do is I'm going to show an example of using Lua with a foreign function interface by essentially accessing Raylib. So I've brought up the Raylib, raylib.com website here, and I've got the examples, and we're just going to look at making the basic window example in Luajit. And so what I'm going to do here is I'm actually going to I'm going to open a file because I have previously, I have for myself Lua libs. I've created a Lua libs directory, and I've got lots of libraries that I've already created for myself for a Luajit. And I've got one that I created for Raylib. And so I'm going to use this as kind of an example of how to create a library that interacts with a foreign library. So a shared object or a DLL, DLLs would be in Windows, and shared object libraries would be in Linux and other Unix-like operating systems. So I'll go over this first, and then we'll actually write a program that uses the Raylib library. So the first thing that you'll want to do is, one of the things that I like to do is when I'm creating a library that I'm going to reuse, is you create this module, and that's why I call it M, and it's just an empty table. And then what happens is you put stuff inside of that table, and then when you're at the end of your module here, what you do is you return it, right? So that way you can require this module and then use it. And I'll show how that works later. But you can find lots of information about modules on the web, both textual as well as videos. So what you'll want to do when you're interacting with the foreign function interface is require the FFI. So I do local FFI, and then I require FFI. And that gives me the FFI library. And the first thing that you want to do is create your C definitions. And of course, in Lua, you use this double square bracket to indicate a string literal that can have new lines inside of it. And then what I did is I just went to raylib.h. I downloaded from GitHub the Raylib repository and opened up raylib.h, the H file. And I just copied some parts from it, right? So some declarations. So one of the things I realized is that, when I write Raylib programs, I'm going to need a color struct, an image struct, and textures. I won't be using those today, or I won't be using image and texture today, but those are things that are very common if you're doing 2D graphics. And then, of course, eventually, if I want to read the keys that are being pressed, well, then you can get that here. So all the enums for the keys. And so it's just as easy as essentially copying and pasting information from the .h file. So in general, that will work if you want to have all of your C definitions. The other thing that you can do is you can copy the function signatures for the functions that you want to use from the .h file. So, for example, init window, close window, window should close, and then I copied some of these other ones because I thought, oh, it would be nice to show that you can put them in there. You can have stuff for cursors, right? Essentially, any of the function signatures that you're going to use in your program, you can just copy here. And so I've got a bunch of those. I didn't copy everything because that would make the file really large, and it's not necessary for this example. Okay, so after you've copied or essentially typed in your function signatures and structs and all of that in your C definitions, then you can actually load the library. And so what I did is I created a little local variable called RL, and I loaded the shared object library. Now, I'm in Linux, and I designed this library to only be used from Linux, so I'm just loading the libraylib shared object library that's already installed on my computer. So previous to this, I had already built and installed the Raylib library on my computer. Now, if you want to, you can actually make your Raylib this library multi-platform. So you can actually have an if statement in here that checks for the operating system that you uses and loads the proper library. So if you're on Windows, you would load, the DLL that you would have installed. And if you're on some other operating system like Mac OS, then you could load its shared object library from its location. But I only care about Linux for right now, and this just makes it very simple. So I'm just loading the library with the one name. If you're on Windows, you can just load the DLL. There's another thing that you can do here is you can define a type, right? So I just decided, hey, I want to be able to have this type and create new versions of this type. That you can do that. You don't have to. Another thing that I do that's very common is you need to be able to convert a Lua string into a C string to pass it as a C string into a C function. And so what I do here is I just create this whole function called string to C string. And I use this all the time in my libraries. And so it just allows me to create a C string from a Lua string. And it just does, these few instructions here. And so that shortens the thing that I have to do. Instead of copying and pasting this code over and over, I just have a little function to do it. Now, the rest of the things I do are essentially the functions that I need to do things, to actually run the code, right? So this one is super useful. This is essentially a utility function that creates a new color for me. So that way I can pass in a table, or I can just pass in individually RGBA functions. And what this will do is this will convert it into a nice little table that is actually a color. Right, and then we can convert that into a color itself that will construct a color struct. So this color up here allows me to create a color struct, and from a table. And this m.color allows me to create, essentially a little table here that allows me to turn that into a struct. So we'll see that in just a second. So then you can see what I did is I created, and this RL here, rl.init window, is actually accessing the C function itself, init window, and calling it. And so what I do is I just wrap essentially every C function with a function that has the same name. Now you could choose a different name, but I like to choose the same name because it allows you to just look at the documentation for, say, Raylib, and all the functions have the same name. So that's what I like to do for that. But notice the reason why I wrap this function is it allows me to have a Lua function that does that just looks like an ordinary Lua function. I can just pass in width, height, and title, and then I can do any other bookkeeping operations inside that. So for example, here I call the actual C function, and notice that I convert a Lua string into a C string. So that way, when someone is using the library, the Raylib library that I've created here, they can just use it as if it's just a normal Lua library, and they don't have to worry about converting strings or doing anything else afterwards. Now, most of these functions are very simple. They're just calling the C function itself inside of it. But I like to do this anyway because it's great to have these little wrappers. And plus, you have to add these things to your module. Otherwise, you're not exporting any of the functions themselves anyway. So you need to create these wrappers. So set target FPS, clear background, begin, and then drawing, and then here's draw text. So here is a little bit more complicated function. So you can see I convert a Lua string into a C string, and then over here, I'm using this color constructor, right? So someone can pass in a color, and then we can convert that into a color struct, which will be used by the C function. So that's nice. So that's essentially all that we need to do. And of course, we return this module after we're done. And that's essentially all that there is to do to create a module in Lua that uses a foreign function interface. So the next thing that we're going to do is actually create a function or create a file that uses this library. So I'm going to go ahead and create a file called main.lua, and it's in this folder called raytest. And of course, I'm using for essentially my quote IDE is LightXL, which I had a previous video about. So what we want to do first is get that Raylib library. Now we could call this anything that we want. We could call it Raylib if we wanted to, but I like to have nice short names. So I'll just call it RL, and then we'll require Raylib. There we go. So now we have the Raylib library, and now we can use it. Now, one of the things I like to do is create a function called main and just put everything inside of there. Now, then I'll have to call main. Now, why would you do this? You could just write your program, your Raylib program, right without having it inside a function. However, if you're going to have a non-trivial program, like a larger program, Luajit is going to have a better chance of being able to optimize the code that you've written if you put it inside a function. So if I were to say make a game using Raylib here, then I would have a bunch of game logic, and there would be a bunch of other functions that I would call, and having all of this inside main allows Luajit to analyze the code and say, oh, you know what? This is actually inside a function. I can do some optimizations here. If it's outside, if it's just in the main file, then Luajit has to assume that those, whatever they are, variables and whatsoever, can change, right? And it's more difficult for it to do optimization. So this is just kind of a nice thing to do as a best practice. So I'm just going to do it anyway, even though what we're doing here doesn't require it. So first thing I'm going to do here is, let's say that you don't know how to write a Lua or a a Raylib program. Raylib has a bunch of examples on their website, and I'm just going to look at the basic window example here. And you can see this, there's not much code you need to write to create a window, which is great. So we're just going to follow this, something similar to this in creating our program. So, okay, so if you don't know, then the first thing that we need to do is init a window, right? So we'll give it the width and the height and the name. And so that's exactly what we're going to do over here. Now remember, we have all of our stuff is inside this package, RL. So we're going to do RL init window. And we're going to give it a width and a height. We'll say 800 by 600, and then give it a title like test window. And then the next thing that we're going to do is we're going to want to set the target FPS. We'll set it at 60 frames per second. And then we'll say while not, let's see, RL window should close. We will do something, and then at the very end, what we'll do is RL close, I believe it's close window. There we go. And then inside of here, we'll have begin and end drawing. So we'll do begin drawing and RL end drawing. Okay, very good. And then we'll draw some text. So we'll say draw text. What is it? Draw text. And then we'll give it the text that we wanted to draw. Say hello there. And then we'll give it a location. Let's see, about half. So the width, so it'd be 400, I don't know, say 370 or something like that. I don't know. In a real program, basically what you would do is you would have this string, and then you would get the width of this string, and then you could figure out half of it. And I'm just doing it kind of by hand because it doesn't matter. So we'll do, let's see, half 300, 280, something like that. And then we'll give it the size of our text, maybe a little bit bigger, 22. And then we'll give it a color. And so remember, we could just give it a table as a color. So we'll do that. And what color should we do this? We'll do it as kind of a gray. So 150, 150, 150, 255. Remember, this is RGBA. So the red is 150, green is 150, blue is 150, and then the A, which is the essentially how transparent something is. So 255 means that it's opaque, right? So we're not going to want to see through this at all. 0 would be completely transparent. So that is essentially that. The other thing that we want to do is maybe clear the background, right? So we can clear it with a color. And we can give it any color that we want. We could even start out, let's just start out with white, 255, 255, 255, 255. That will be white. And that essentially is our program. That's all that we need. So we can go over here, and here I'm already in this ray test, and you can see we've got our main.lua file. And we're just going to use Luajit and call main.lua. And we see that our window works here. It's 800 by 600, and we've got kind of in the center. We did pretty good with this. And we've got hello there with the default font that it has. So pretty nice. And so we're just going to close this. And then what we're going to do is, actually, if you want to have a little bit more maintainable code, you can also create local variables here. So we can create our colors, right? So we can say, in fact, what if we converted this to teal, right? We could have a background which is white, but we could change it to be teal by saying we're not going to have any red, but we're going to do some green and blue. There we go. And then we could also create a local gray for our text and just use this here. And we'll call this gray. There. So now we've got some variables. Let's see if this works here, right? So if we call our Luajit, maybe I did something incorrectly. In function clear background. Did I do something incorrect here? Clear background needs to have a color inside of it. Let's say teal. There we go. And now we have a teal background with the gray text, right? And we could do something even more egregious, like we could create something for, instead of gray, we could have something like red, right? So we could do this. Now, of course, now I have to change the color. It's not gray anymore. Call it red. Now it should look very egregious, right? So we've got this teal background with the red text. And so you can see that's how easy it is to use the foreign function interface in Luajit. It is one of the easiest foreign function interfaces that I've ever encountered. In fact, it's even easier to use than Shay schemes. So Shay schemes I hold in a very high regard, but Luajit I would say is probably one of the best foreign function interfaces I've ever encountered. And as regards to, say, performance, Luajit has, I believe, the best performance of any foreign function interface in existence. And the reason for this is that Luajit is able to JIT out the locations of the function. So let's say, okay, in this, basically this rl.begin drawing, right? So begin drawing ultimately calls the C function begin drawing. Now we're using the foreign function interface, which means we're loading in a shared library. Now what happens in a program is when you load a shared library, you load it into your memory space. And then there's this mapping that happens where you have to say, okay, there is this string called begin drawing. And I have to look for that string begin drawing in the library itself. And then that library will have this entry that says begin drawing. And here's the address of the begin drawing function. So then you can call that address with the proper arguments, and that's how you call a function from a shared library. Well, Luajit can take away one of those instructions, right? It can go into that library. It can say, okay, I'm going to look up begin drawing, like here. I'm going to look up begin drawing, and you know what I'm going to do is I'm going to, where's begin drawing here? Actually, it doesn't matter. It could be any of these functions. But I'm going to look up begin drawing, and what I'm going to do is instead of having to go through that indirection, which is necessary in a compiled language, I can go and at runtime, I'll load in the library, look up where these functions are, and then I'll just patch that address directly in there, and I'll call the address directly. So ironically, the Luajit function calls of dynamically loaded libraries has less overhead than C itself, right? So it actually has less overhead to call a dynamically loaded library function than even C does, which is kind of crazy. Now, of course, the code itself, like other Lua code that you've written, won't be as fast as C. But this is that's actually kind of an interesting just tidbit of information about Luajit and how it works. So, but that's essentially it. That's all I wanted to show, that you can create your own libraries very easily, and then you can just use them very easily. It's actually that simple. So I would encourage you to go and try this out. It's actually just a lot of fun. Like you can try SQLite, try using a cryptography library, you can write your own C libraries and then import them in here. Try that out. I've actually done several of those. Maybe I'll show that in the future. But anyway, that's about it. And have a great rest of the day.